the opportunity on this panel with these other luminaries. So thank you, Rich.
So we have plenty of time for questions, which is great. I want to ask one question to kind of get us started off of all the panelists, and this is a question about risk. In the commercial world, as a business, we measure risk in different ways. And I would argue that if we had the ISS, when we were planning on going to the moon, we still may not be there because we might still be testing. When is enough testing enough? How do you measure an acceptable risk level, and how sure do we need to be of certain systems before we take the risks and go to Mars? Who wants to start? Go, Larry.
I'll let one of the engineers go.
How do we measure risk?
How do you measure risk? So we have lots of ways of measuring risk, right? Systems, processes that work that. So it's a real function of the experience base, I think. I said as I was talking, we have lots of experience going to low Earth orbit, and so we understand the things that can happen and can put systems and plans in place to mitigate those risks. If you're going into unknown scenarios, and as we go to Mars there will be more unknown scenarios, the risk is a different animal because there are things that aren't within our experience base as much, and things that we'll have to anticipate and put plans in place to deal with. When do you know it's enough? Boy, there have been, there's a whole culture that within NASA as it currently exists that deals with that. Goes through readiness reviews, goes through testing, and it's almost a, when you get to the final analysis, it's a sixth sense that folks have about we've done what we need to do and we understand the risk and we're ready to go. I don't know that there's a mathematical equation that you lay out and you say A plus B, hey, we've done it, we're ready to go, and it's the risk. It's an intuitive art to some degree.
Great.
I think a lot of it has to do with risk versus reward. And everybody evaluates those differently, and the government evaluates it differently than a private enterprise. And a private enterprise that's private, for example, may evaluate risk differently than a publicly traded enterprise. And so, when governments in some ways are inherently risk averse, but in some ways they're not. I mean, if you look at the Department of Defense, they have a different risk profile certainly when they go into battle than maybe with technology development. So a lot of it really depends on the particular situation. And again, I think for the country, when we choose to enter into some sort of conflict, a lot of it has to do with, is it worth putting lives at risk for the societal benefit of helping to protect others on that we're presumably trying to protect. So it is a difficult equation. I agree with John. I don't think it can be necessarily computed mathematically. When their lives at risk, certainly during the Apollo era, we had a much different risk tolerance because it was perceived as being a national imperative, having to deal with national security, in fact. So I think a lot of us in the industry think we need to get back towards that. We need to be willing to take more risk. I think certainly that would be SpaceX's and our founders' sort of philosophy, and that's one of the benefits to come back to the point that has been talked about a couple times on this panel that is related is commercial versus non-commercial. And from my perspective, commercial just means it's an entity whose primary objective is to return a positive return on investment for their shareholders, or even it can be a shareholder in some cases, not SpaceX, but in some cases, a single shareholder. And Boeing is obviously commercial, as John talked about. He's got there's a division that all they do is sell commercial airplanes, and Lockheed Martin, even though the majority of their business is with the government, they're still a commercial entity that's trying to return a positive return on investment for their shareholders. And a lot of it has to do with how the government engages with the commercial industry, and I think that's where when they defined the Commercial Orbital Transportation Services Program, that's what they were trying to emphasize, which is this is going to be a different way of doing business, at least in terms of NASA's exploration mission, than the way they've done things in the past. With, you know, defining the requirements, setting down the objectives, using fixed price milestone-based contracts. That's something other parts of NASA had done and other parts of the government do frequently, but in terms of the exploration office, it was a different way of doing business. And so that actually allows the private sector to take more risk on our side of the equation when it comes to doing development. As I talked about, if we have an engine failure in development, we're able to turn it around more quickly. It's less costly, takes less time. And I think that that's kind of where, that's how you define, in my opinion, the commercial and the distinction between the way things have been done. But, the Delta IV, the Atlas V, the Falcon 9, Taurus 2, all of the rockets flying today, above the smallest ones, were all developed using fixed priced, milestone-based commercial contracts. And so it can be done. Boeing certainly knows how to do it, and Lockheed knows how to do it, and most of the contractors know how to do it, and even ATK is now saying they'll do it with their Liberty vehicle. So I think that's a big part of it, and that does change the risk equation, though. It puts, in many ways, more risk, I think, on the commercial companies, but it allows us to operate in different ways.
Correct. And Tom, Lance, do you want to?
Yeah, no, I was going to echo a lot of what Larry said, but add another layer of it. A private individual makes a risk decision based on different parameters than a government or a commercial entity, and that adds a different element to the discussion here as to who's taking the risk and why, and which vehicle they're traveling on, and how well it's been tested, and who's flown on it before, or who they're flying with. It's going to add complexity probably more than remove it, but it's in some cases it may actually simplify things.
Lance?
Yeah, I think the unique distinction for this panel being commercial is that even in our I know you're talking about mission risk, but we live every day in business risk. We're laying our money on the line, and God, I've heard recently somebody lament why we don't have multi-year funding, and I said I just do for multi-month right now. Or multi-week at this point. So it's somewhat inherent, and I think Larry's kind of saying in the individuals that you're even seeing here that we are risk takers. I'd have to be running an entrepreneurial firm in the space, human space travel. It's more of a personal opinion built on my long experience at NASA and in the private industry, but I look at this and say, a historical perspective of humanity and our perspectives, when we were trying to go to the moon, or we were trying to break the sound barrier, there were lots of people saying, well, we can't do that, or we don't know what's going to happen. A lot of people may die, and some people did, and sometimes it didn't. Sometimes we overcame it. These discussions, to me, I don't quite understand them all the time. I think you just make a decision. You identify to yourself, like you said, in some sense, you identify in your head that risk level, and then you decide and you go. And there will be, you will not have all the answers when you start. If we say we want to go to Mars, and people say, well, what about the radiation? I am sure there's a list of 20 things when they were going to the moon that they said, well, we don't know if this is going to kill us or this is going to kill us. I'm sure they had those lists. And you're then driven to go to solve that issue. And I think Larry is trying to make that point maybe about going to war. I mean, you don't come up with every contingency and say, we're going to be completely safe, we're going to get there.
We're approaching this kind of reverse, that while it is tactically risky to do the exploration that we're talking about, strategically, in my opinion, it's riskier not to do it, in that we're phrasing the risk in doing something. It's kind of like how we approach climate change, actually. We're phrasing the risk in doing something versus the risk really, in my opinion, should be approached by not, what's the risk in not doing it? And maybe that's what this community should be focusing on when it comes to public outreach or discussions with the government or what have you, that really, and we heard some of this yesterday, that not doing it and just sitting around, not exploring, is not is actually, could be more risky than not.
Any comments?
Well, certainly you reduce the risk to zero if you don't do it, but there's no reward. So I think what you're saying is the risk of getting no reward goes up if you don't do it.
And I think a lot of it has to do, yeah, the risk versus reward. I mean, it depends on what, I guess, people think we're going to achieve by going to Mars. Our founder, Elon, thinks that, it's important for society and the future of mankind to make us multi-planetary because we don't know what's going to happen to this planet. And it's not that you necessarily, you don't buy insurance because you think you might get hit by a bus, but you buy it because you might. And in terms of the planet and the future of the planet, if you're looking at this from a perspective of what's the cost of not doing it, and the cost of not doing it is in some time, in the future. I don't think anyone thinks it's in our lifetime, or probably not even our children's lifetime, but at some point in the future, if we make this planet uninhabitable and that's the end of humankind, then that might be how you define the risk of not doing it, and then that obviously changes probably your risk tolerance. And so I think that is something that probably it's inherent upon the community to talk about, which is, why is it important that we do it? Because therefore, if we don't do it, the risks are X, Y, Z.
We have a question back here. Can we get the microphone over?
Can I follow on to that?
Yeah, sure, Lance,
question?
go ahead.
In addition to kind of the philosophical of, who we are and, saving humanity, I mean, it's even the benefits back here. And I know it's a tired argument, spin-offs, et cetera, and we will talk about the integrated circuit was invented, but that stuff's real. I mean, our economy in the U.S. over the last 60 years, since World War II, was built on technology innovation. The quality of life we have in this country and around in places around the world, whether it's your salary or the cell phone that's in your pocket because the chip that's in there and the satellites that hooks up in, and the communications that evolve from that, and then the social benefits of now knowing what's going on in the world and being able to connect. That is, I mean, you can't, it's, like the Visa commercial or whatever, it's like, invaluable. I mean, you can't even calculate all that. And that comes from us pushing ourselves to the very limits on a technically challenging project. And I feel like we're not pushing ourselves hard enough now, and I don't think our country as a whole understands the value of that to us. I mean, we talk about it, I'm constantly talking to leaders all over the place, and it's just, you get the, yeah, okay, you got anything else? We got to grow ourselves out of our situation that we're in. So I appreciate you bringing up that point.
Okay, I'm going to just get this gentleman, or do you want to go, Buzz? I'm sorry, will you yield the floor to Buzz Aldrin, please? We'll come right back to you.
Yeah, basically the question has to do with how soon and in what form can we have a test bed structure of some sort at the ISS to test out the equipment and configuration and the support of missions going beyond low Earth orbit. And when I look at that question, I say to myself, well, now let's build a big container, and we'll call it a large container, and it'll have everything in it, redundancy to be able to take people to someplace like Mars and back. So I look at a large one, and then I say, now, let's compare that with two mediums that are about the same size. And if one fails, then I still have the other one. So if I can eliminate critical items in both of them that would cause both to fail. Now, if I take the two medium and let one grow smaller and the other one grow bigger, pretty soon the small one disappears and I'm right back where I was with the big one. So somewhere in that trade space, I feel, is what we need to depart as a specialized spacecraft system from Earth orbit outward. We need the specialized spacecraft, commercial, to take people to Earth orbit. And when we get somewhere, if there's an atmosphere, we may need a lander of sorts. Now, I feel that as you do this trade space of two mediums, when you get to a small and a medium large, that's pretty ideal. Turns out we're already working on a small one that's called Orion, except we'd like to specialize it and not have it take humans from the surface of the Earth up to orbit and back again, to have it go outward. So we need something like an Orion that's small, but now converted into a medium large, about 3 times that size. Can we get a test bed of that nature and begin to put similar equipment, but avoid the single point failures, and begin to get a test bed at the station? We might call one of them Orion Exploration, the small one, and the other Orion Habitat. Now, when you get to some place like Mars or an asteroid or back at Earth, the small one becomes what we would call a space taxi. It takes people, it's smaller, less velocity, less fuel is required to take it from a low Earth orbit to a medium orbit to a higher orbit around the Earth, around Mars. Now, the medium large, the Orion Habitat, is heavier, bigger, so we don't want to move it around, but it becomes a habitat in low Earth orbit, medium, but it also can be landed at a vacuum object, like the moon. So you can sell it to the Chinese so that they can use it as their habitat. And we can also land it on Phobos, and we have a taxi, the Orion Exploration, that can go to Deimos and other orbits. So to me, that's a good starting point, but where we need to really concentrate is where can we get the shell, about the size of a U.S. ham, and get it up at the space station and start filling it full of test equipment that Paragon and other people can come up with. And this is what my small group of guys called Unified Space Vision have been trying to do. Unified, well, instead of vision for space exploration, it's unified space vision, and we unify 5 things. Exploration, development, leads to commercial, then we get science and security. Those 5 things are what are needed for a national space policy. And when it becomes unified strategic space, then it's not just national, but it's international. How our nation relates with those 5 things with other nations. And I happen to be calling that USS Enterprise. Unified Strategic Space Enterprise. It's not an advisory group, but it's an information disseminating to tell the American people and people all around the world what are the elements of space policy and how are we proceeding to unify them within the nation and then strategically to interface them with other nations.
Thank you.
Amen.
Amen. So be it. All right, yes.
I just want to comment. I think that vision's brilliant, Buzz, especially the part about the big habitat, just filled to the brim with Paragon equipment.
Go.
Everybody, whenever anybody else wants to build that.
You better ask your question quick.
I think so.
Go ahead.
I don't have as good a pun but that's a very nice vision too. The notion of error or risk in when you do something you don't know about is, of course, what statisticians call type 2 error. The risk that you let a guilty man go free, the risk that you find a fatal flaw undiscovered, leave a fatal flaw undiscovered. That type 2 error is very well defined. But what this fellow alluded to is something that can't be put in the type 2 error, the risk of not taking the action. And in our situation in the United States, I think we'd be well served to understand the great synergy between exploration and green energy and oil independence and a lot of high tech that needs to come on stream, because there's such a great overlap that whether you're commercial or whether you're government, or whether you're in between, recognizing the synergy in all these things helps everybody get along a little faster, and you cross-pollinate from one thing to the other. So I was curious what the panelists thought about that notion of synergy and whether they've applied it in any case, any sense in their activities.
Anybody want to comment? Are there, I believe, and I've been working for a while on the concept that the ISS is, and LEO is certainly a platform for applications and services, and those might be energy and green opportunities as well, as you discussed, but perhaps Mars is a platform too for applications and services in the future. Anyone want to talk? What's the killer app for ISS and deep space? What's going to drive the market to go there? Is it SpaceX? Maybe it's just smart, wealthy people wanting to go and visit Mars and have some fun.
Yes, I don't think there is one single killer app. I think it's going to evolve, and I think we've seen already that space has been for a long time a domain of governments and certainly manned space. It's becoming increasingly an arena for private individuals. I think there's another market that you can layer on top of that, which is commercial astronauts, people who are being paid by commercial companies to go up and do research. I know that's an arena that Mr. Bigelow is quite interested in, alongside getting more countries involved in manned spaceflight. So I don't think there is a single killer application. I think there is a combination. You've got to layer different marketplaces on top, and each market is going to evolve at a slightly different pace. But as we start to send more people into space and we can raise the dialogue on a much wider basis, and the awareness of space becomes more prevalent in the minds of the regular population, I think then you're going to start to be able to build a consensus and say that deep space exploration, whether it's a return to the moon, to go to Mars, or to go anywhere else, starts to become important. And it's going to be important for different people for different reasons. But it's going to take time for that to evolve. I think as more people get to go and experience space privately, commercially, or in which other form, I think it's going to become a more common topic of debate. And we're going to get back to that point we were 30, 40 years ago with the Apollo era, where people were truly, genuinely excited about space and what the what prospects it's held. The last couple decades, to be honest, have been pretty dull. Sorry.
Yeah, I'd say that you have a great point, sir. And if you think about how the space program evolved early on and its benefits back to society, I mean, there was a revolution in electronics and communications that we developed. It was necessary for those space flights to happen. And now, as I talked about before, are now, embedded in our society. As we look at these longer missions, the technology revolution that you need to have, I believe, is in kind of propulsion, which is, and energy, and that's all based in kind of energy. So again, we're having energy issues here on Earth. We would like to find alternatives. So the technology development and the exploration we do in energy will help significantly. And the other place, the second place, is life support, because if you look at sustainability of humans on this planet, and we're talking about an environment, again, we're going to find out how to better recycle water, air, issues. And, I touched on it with our solid oxide electrolysis of 100%, recycling of carbon dioxide that you can start looking at. And we're looking at applying that in all different ways. So, I mean, you take it with a grain of salt, because that's the business I have. But I really do see it as, yes, this space program can drive that technology innovation that we need for this country and for this world right now, which is energy and sustainability, and those equate to your propulsion and life support. And yeah, we do need to push the envelope.
We have a question right here. Tom, open up The Economist magazine one Friday and I see this full-page ad advertising a translunar trip in a Soyuz capsule. I consider it foolhardy, but incredibly brave. I start researching, and unbeknownst to a lot of people, the Soyuz started life analogous to the Apollo capsule. It was going to be part of their manned lunar program. That's how it started. So then more credibility grew up. I said, maybe this would work. And so to me, it's easy. You put the chemical booster on the Soyuz, you can escape the atmosphere, have your orbital mechanics right, you get in that nice little thing, you go around the moon, and now we're coming back to Earth where you have a 1 or 2% tolerance error when you go into reentry. That's where it's life or death, and you have incredible technical challenges to make it happen. Has your company given a lot of thought in the Russians to this, all the challenges of really making this happen?
Absolutely, yeah. A lot of those, I'm probably not technically qualified to talk about any of them. I don't come from a aerospace background, but yeah, absolutely. The mission wouldn't be endorsed if some of those studies hadn't been conducted and there was a plan on how that's going to happen. I just can't share those details with you at this point.
Yes.
So we opened up the dialogue with a question on safety. So a question, I guess, mainly for Larry and John, maybe Tom a little bit. But my question is, the difference between, at least in my perspective, the government versus private industry is you've got a company that needs to sustain itself, whereas the government is there, and in the event of a catastrophic failure for whatever reason, the government doesn't fold up and go away, but potentially private companies could suffer pretty significantly with those types of failures. So I guess I'm curious to know what sort of recovery plans SpaceX and even Boeing has, even though obviously they've got other means of but what sort of fail-safe do you have to protect against a single catastrophic failure, or maybe even two?
Well, there are lots of businesses that deal with that every day. The commercial airline industry deals with that every single day, and it's not something that cannot be overcome. So we are a for-profit venture, and we recognize that there are going to be risks with human spaceflight. Our vehicle will have flown many times before we are going to put people on it, but unfortunately, people die in this country every day involved with businesses, and these businesses, there's insurance, there are ways to mitigate for that. There's, in some cases, the government does indemnification to sort of help a particular industry. We've had those discussions with the FAA. Certainly, it's the government's job to try and protect its citizens, but if you look at it, people climb Mount Everest all the time, and they take those risks, and they're real, and not everybody comes back, and unfortunately it is an inherently risky business, and there's really not that much you can do to eliminate that.
So I would add that this is a big deal internally. When people think of Boeing, that brand is big, safe transportation vehicles. And the risk associated with having an accident and having that be a very visible thing and tied to the brand is pretty huge. When they trade internally the financial impact of that damage to the brand against this little money that Elbon thinks he's going to make in this business, it's a difficult discussion. So I can tell you it gets a lot of... Now, we have the same kind of challenges as we build commercial airplanes. The risk is a lot better understood, but the similar challenges. So within the company, there's a very robust mission assurance process that's independent of programs and reports up to John Tracy, who's our chief technologist, and reports right to Jim McNerney. And those guys, that team of folks is going to be all over us. They are now, and they'll continue to be, to make sure that we're doing all the things that we need to do so that this system is safe. In addition to that, we're hopeful that NASA and the FAA are going to be involved in kind of being an additional independent review of all this. The designs that we've selected are really focused on being simple and safe so that we can reduce that. So everything's being done that can be done to make it as safe as can. Your question, though, was what if all that fails and there is an accident, which is a possibility. So we'll have to be prepared to do that. We'll have to have done from a business case the analysis that says we can survive that. We'll work insurance for missions. In our test program, we've assumed that one of our test flights is going to fail, for example. The cost of the rocket is there. But it's a hard problem, and it gets a lot of scrutiny, and it's got to be dealt with.
Thank you. Yes, in the middle.
Rich, do you mind if
Sure,
I
go
know
right ahead.
Michael didn't ask me.
Sure.
That's all right, I'm going to pitch in anyway. John touched on it earlier. A lot of this is psychological. It's what we humans construct and what we're willing to take as risk. I mean, there's all kinds of statistics, and I mean, one of them, a great example for him is that the airlines, whenever there's a big aircraft carrier goes down, there's cameras there. It's this visual thing, and everybody gets upset. Okay, but and it doesn't happen that often. It really doesn't. I mean, they've got pretty safe systems. But every day we lose 5 ships at sea. Every day. They go down, and some of them are big passenger ships, some are the big car. I'm not talking about like a little sailing boat, I'm talking about like big ships. They go down. And there's no outcry that we need to revolutionize, change the risk, and I personally think that's because we don't see much of it. There's nobody out there by the time they get, most of these times somebody gets out there for the SOS call, it's gone. It's under the sea, gone. There's nothing to see. Now, having said that, I'm saying this is a human construct. Having said that, for my company, we got to succeed, because you know what? My company's in life support. If I'm not supporting that life, I can't have really much of a business. So my company's got it. We pay very close attention to this stuff.
Thank you. Yes?
Tom, you made the comment just a few moments ago that the last couple of decades were kind of poor. And there have been comments over the last day and a half to suggest that the public getting involved in this is really not perhaps where we would like it to be in terms of enthusiasm. My question is, given the commercial sector of this, how do you all view trying to get beyond what you all have alluded to as well, is this is an activity from a commercial perspective, it's an activity for people with lots of money who are really smart. They just want to go do this stuff. How do you get beyond the elitist perception of this to where the general public then thinks that this is an exciting venture?
It's a very good question, and it's something that we have spent a lot of time thinking about and talking about, and there are plans already in place. And I think you can engage people at different levels. And we're talking here about LEO, but there is suborbital space flight as well, which is going to start happening sometime in the next few years. Depends on who you believe, and that's going to bring it to a point where, okay, it's not the same. You're only spending 5 minutes in space, but it is space, and you're going to have thousands of people within a few years of those vehicles starting to fly who will have been and seen Earth from an incredible perspective, and to be able to share that. And I think it's going to inspire an awful lot of people to say, well, what's next and what's beyond that? But when you bring spaceflight to that point where it's a few $100,000, then it's a lot easier for educators to fly, for researchers to fly, for just regular private Joes to win a ticket in a raffle or in some other promotion. And it's going to become a lot more real for a lot of people. So even though the price is going to stay high from an individual perspective, I think there's going to be a lot more of this sort of tangibility that this is something that you could really do as a private citizen. And since the end of the Apollo era, I think this has been lost. It's been a domain for government astronauts, and there's just over 500 people in 40 years who've flown to space. That's not a lot. It really isn't. And so, governments do incredible things, but they have a habit of keeping them secret or making them extremely dull. That's just the way I think we can really re-energize if we start to get regular people flying more.
Will the first man or woman on Mars be a government employee or not?
It's a very, very good question. I think there is. I think it's not predefined. It doesn't have to be a government employee.
I think it doesn't have to be, but I think it's probable.
Probable. Yeah.
I mean, I actually think that there's not necessarily a correlation between the elitism and the general public excitement. I mean, the astronaut corps is the most elite club in the world, and yet there has been historically tons of public excitement about the Apollo program, certainly in those days. I think it was exciting because it was something new. I think it's gotten perceived to be, although I think those of us up here on the panel in the industry know there's not that much that's routine about space, but that's the perception that it's become routine. So we need to start doing things that are new. And I think it's an exciting time for the industry because we're starting to do a lot of new things. And even though the SpaceX flight, our last flight, we became the first private company to go into orbit and come back down, even though that was done, in the Gemini era program, it was still received with a lot of excitement because it was something new, and meaning that it was a private company doing it. And so I think that bodes really well for the industry and the building of excitement for all of us. And I think there will be more people. I don't disagree with anything Tom said. There will be more people actually going into space, which is a great thing, but I don't think that that's necessary for the excitement to build.
Let's make sure we get this question in the back. Thank you.
For Mr. Shelley, please, are you at liberty to say whether you approached any other potential suppliers for the circumlunar flight other than the Russians? And second part, are you able to say what made the deal a viable proposition for the Russians?
I don't think I can answer either of those questions.
There you go. I will say, and if you were a member of government, you probably couldn't have answered those questions either. I will say too, perhaps we talk about commercial activity. Perhaps this isn't about commercial space as much as it's about competitive space. We have a market that's enabling us to compete, which is driving innovation and driving down costs. And I think that that's a necessary component to getting to Mars. Let me ask you a question about ISS, and this is maybe a controversial question, but is ISS necessary for us to go to Mars? Maybe, or is it a necessary component?
I guess I'd offer a couple thoughts. I think it's necessary, pretty much for sure, as a test bed to test out technologies and operational scenarios, etc. We could debate long and hard about different architectures, and I'm not sure where you're going with your question, but is it necessary from an architectural perspective as a jumping off spot? We could come up with architectures that would do that and architectures that could do it without it. So I don't think you can say it's necessary from that perspective. But certainly what we learn by putting ISS there and how we use ISS is a very necessary step in developing the capability to go to Mars. Okay, that would be my 2 cents.
Agree?
Yeah, I agree.
Okay.
That's one of my presentation.
Yes.
Hi, I've got just a quick question.
All right, go ahead, please.
Just on the, just getting back to that idea of how commercial can facilitate beyond LEO exploration. It sounds really like the bottom line is that that's still going to be a role for NASA, that perhaps SpaceX or Boeing or other entities will be providing the technologies to help do that, but it still might be more like kind of the old model rather than the model of someone trying to build a space hotel or trying to open up a private joint on Mars.
So that was what I suggested, is that would be the best path forward. I think the thing is that kind of exploration is such a grand scale and so much development is required that it takes government leadership to get done. Doesn't mean there aren't roles for lots of people and lots of entities to play in that. But I think it would be very difficult to put a business case together to do a industry-led development of a capability to go to Mars, not understanding the parameters that you need for a business case to do that.
I think a lot of it's the industry-led versus government-led, and not so much the roles in which commercial entities are going to play. I think it's most likely, as most people would agree, is likely going to be government-led, and I would say, probably a very good return on investment for a government-led. I mean, I don't know if anybody's ever done what the sort of government or the American return on investment for DARPANet, which ultimately led to the internet. But wow, for a very tiny investment, think of all the wealth that's been created in the United States. And we're kind of at a similar crossroads in that we're running these huge budget deficits. It's not clear how we're going to get our way out of this path. And I actually came to Washington around in the very early 90s when it was not clear what the next thing was going to be, and it looked like Japan was kicking our butts in cars and photocopiers and cameras and Walkmans and all that, and it really looked like we were losing our edge. And then the mid to late 90s, the internet came along, and it changed, brought a tremendous amount of wealth. It changed the entire equation. I'm not saying that space, low Earth orbit, is going to be that next thing, or Mars, but it seems, I can't think of anything that's more likely to be that next thing.
Yes.
Steve Steve McDaniel with ExploreMars. It seems to me that I'd like to know how each of you might respond, because you certainly come from different resource backgrounds, Boeing, and different resource backgrounds, is that you each keep speaking of 1G applications fondly, because they seem to be driving a lot of the economics. In other words, sure, you've got to have 1G pay-as-you-go in order to drive the micro-G and the zero-G applications. How much do you think it impacts your progress on the micro-G and the zero-G applications to have to devote a lot of your resources, or some of your resources, to the 1G applications? Do you understand my question?
Maybe
How
I
much,
do. I'm not sure I
say
follow
for
what you're
instance,
saying.
the life support systems, you're producing a commercial version of that you may be able to utilize in a 1G application, okay? And you are also doing that for micro-G and zero-G applications. How much of your resources do you have to devote to the earthbound applications that don't get devoted to the micro-G applications?
Well, I'll just speak directly about my company. We're vastly focused on the microgravity. My company was founded on a vision for space travel. And we've been, like a lot of small companies, I mean, we're about 18 years old, and we had to fight and struggle. There were, for most of our company's history, we were small, 5, 10 people. Only in the last 5 years or so, we've had about 40% growth every year. We're doing really well. It was built on the intellectual property development, knowledge growth in the company. But, now we're at a point, quite frankly, it's mostly space, and now as our strategic officer, over this past several years, my job has been to diversify back into, 1G to build a more solid business model for my company, because I'm not like Boeing, who has, is part of a huge conglomerate, has, aircraft and everything else, or a lot of my other competitors. If I looked across the spectrum in which I play, and it's all big companies who have multiple lines, not even in space and other ways. So my company's diversifying out diversifying back in those areas. We're developing now unique dive suits for the Navy that are based on kind of spacesuit type technology, completely isolates and protects them from places like Hurricane Katrina, or not necessarily the radiation, but all the toxic chemicals you might find in Japan's waters. But I can say for us, it's mostly the space. My company is focused on it. It's a small entrepreneurial company. It's built on our passion, our desires. We choose and pick what we want to work on, the fun stuff, and therefore that's where we work. But it's a very different game for me than these guys. I mean, I'm 100 people.
Yeah, so I think I understood your question, but if I don't, you re-vector me here. The division that we're a part of, Space Exploration is the name of the division, focuses on space stuff. And if we develop technologies that other parts of the company can use, we would certainly make those available. Unfortunately, at this point in time, we're pulling from other parts of the company the technologies that have been developed on other programs to apply them to what we're trying to do more than the other way. So we aren't actually leading that. We're pulling stuff in. Boeing as a company hasn't really taken hasn't made it a focus to take technology that's a spin-off from space or even aircraft and do other 1G kind of things with that technology. Most of that IP is owned by the government because it's developed on government programs, and other companies certainly do that. But it hasn't been a focus of our business plan. So we don't spend a lot of time devoting many resources at all to taking the applications that we have and looking for, the technology we have and looking for other applications.
So good news, they're not wasting all their time on 1G. Or resources. So we have about 5 minutes before we're going to break, and I guess I'll ask a real open-ended question. Just if you're all willing to pontificate a little bit, if you were to guess, when do you think we'll be on Mars? What year? and why.
Can I give
And
what
you have to do it in 5 minutes.
Can I give what I've learned to be a standard space industry answer?
Sure.
About 2 or 3 years.
No speculation?
So I'll just pontificate, that's what you asked me to do, okay? I think there's a lot of challenges to going to Mars. It always is more difficult when you start looking at what the vehicles have to be and the problems that are there than it is when you're making view graphs. But I really hope that we can stay on a steady path of getting there. Our space exploration efforts have really struggled over the last while because we can't stay focused on a particular direction. We switch and then we kind of waste the effort that we've done. So I don't know if you want me to pick a date, maybe August 12th of 2037.
All right. Okay. There you go. Got a date. Do you even want to go through Larry?
Well, how do you define being there, I guess?
No, that's a good question. We had a great debate last night with Miles.
You can tell Larry's a lawyer.
Humans versus robotics, too.
play
Let's
one.
just talk about human space travel.
Yeah, I think a lot of it depends on, is there anyone in the audience who would be willing to go one way?
Yes.
Okay, well, I think that makes it a lot sooner. It's that simple.
He'll be out in the lobby after this.
But you laugh. I mean, I think the reality is there are a lot of people out there who might really be willing to go one way. And you know, when the settlers, came from Europe, a lot of them didn't know whether they'd be coming back. And when a lot of the settlers went from the east to the west to California, most of them assumed they weren't coming back. And I think that might be, I mean, that certainly makes it a lot easier from a technical perspective, without a doubt. So.
Okay.
I just want to add a calibration. I started working on the space station program in '86, right after Challenger. And when I started working, it was supposed to be assembly complete in 1992 in celebration of Columbus' 500 year of discovering America. So, and we made it by, like 2010. Yeah. So, it's just, those kind of big programs are just, you got to work through them.
I preface it by saying my idealism has never matched reality. So I've always been sadly disappointed. And I'm not going to say a date because my perspective is when people, a lot of times, whether I'm talking to my family in the middle of Pennsylvania or I'm sitting beside somebody on an airplane, they ask me those kind of questions of when are we going to do this, when are we going to do that, when are we going to, looking back at history, what I realized is it's impossible to predict those kind of things because you cannot take a linear extrapolation of the historical facts and apply it to the future. It doesn't happen that way. And again, I'm the idealist, which says generally what happens is you have some paradigm shifts, some new invention or whatever, which you think it's going to be 20 years, but it ends up being 10 because there's something you did not predict was going to happen. So I tend to think these things will happen much sooner than my colleagues in the space industry, though, as John might point out, in reality, I may be wrong most of the time, but I'm going to still walk around with my rose-colored glasses on and say it's going to be closer to Tom's answer than to John's answer.
Well, I think an interesting way to rephrase the question might be, especially for those that have been in the industry for a long time and know technically, that if it were a national imperative to get a living human onto the planet of Mars one way, how soon, if the industry got together and that was a national imperative, I think before the end of the decade, quite fairly simply, right?
I mean, that's a good point, and that's, John Logsdon's recent book, and I'm not getting any royalties off that, by the way. But that was his book on, the decision to go, and we did it, and, to the moon, and we made it imperative, and we went. We spent the money we won, and, we're not spending anywhere near that right now on this stuff, so it's not as much of an imperative, so it's a good point.
Well, I know that we are closer to Mars because of the innovation and leadership of four of you and your companies and what you've done and contributed to the space community. So I thank you for contributing here. Chris, is there anything you want to say before people are excused for this period? Okay, well, thank you all for listening to the panel, and I appreciate the panelists for being here.